In this video, we're going to discuss multiplication and division of monomials and polynomials, monomials times polynomials, and monomials divided by polynomials, and polynomials divided by monomials. We're going to start with multiplication. And let's look at an example. Let's say I have my monomial x, and I am multiplying this monomial times this binomial x squared plus 6. What we need to do over here is we need to multiply every term in the binomial by this one monomial, which isn't too difficult. It's just like distributing. We're distributing the x over the x squared, and we're distributing the x over the... So let's see what this becomes. X times x squared is x cubed. X times 6 is 6x. And that's the answer to the question. It's not so difficult. Let's look at another example. Here we're going to have 3x squared y being our monomial. It's still a monomial, even though it has a bunch of different parts to it. It's still a monomial because it doesn't have anything added or subtracted. And we're going to have to multiply that by 9y plus x. And again, we're going to distribute the 3x squared y over the 9y and the 3x squared y over the x. And let's see what we get. 3x squared y times 9y. So we're going to multiply the two numbers. We're going to multiply the 3 times the 9. 3 times 9 is 27. The x squared, there's nothing we can multiply that by. And the y times the y, we can multiply those two parts by each other, and that becomes y squared. Next we're going to multiply the 3x squared y by the x. So 3x squared y times x is, so this is plus 3. We have an x squared and an x, so we can multiply those because they have the same base. 3x cubed y, and this is the answer to the question. 27x squared y squared plus 3x cubed y. One last example. Let's say we have xy, and this is our monomial. We want to multiply this monomial times y minus 3x. So again, we're going to distribute. We're going to distribute the xy over the y, and we're going to distribute the xy over the 3x. And let's see what we get. Xy times y is xy squared, because the x stays alone, and the y, we can multiply the y times the y because they have the same base, and the exponents don't matter, and the coefficients don't matter. And then the xy times negative 3x becomes negative 3x squared y, because the x's are the same base, so we can add their exponents, and the y just stays alone because there's nothing we can multiply it by. Let's move on to division. We're going to start with an example of when we are going to divide a binomial, let's say x squared plus y, divided that by x squared. Now what you might be very tempted to do, which I'm going to do in red because it's totally wrong, is to cancel out the x squared over the x squared and then just be left with the y. That is totally wrong because this binomial in the numerator is attached to itself. So you can't just divide part of it by the x squared and not the rest of it by the x squared. What you would have to do instead is rewrite this question. So the original example was x squared plus y over x squared. What you would have to do is you'd have to break it up. You would break it up to x squared over x squared plus y over x squared. So we're dividing the first part of the binomial by the x squared and the second part of the binomial by the x squared. Now what you can do is you can cross this off. This becomes 1, because x squared over x squared is the same thing divided by itself. It becomes 1, and we're left with plus y over x squared. We do have to keep this term, so it doesn't really look so nice, but it is still a binomial. It's 1 plus y over x squared. Let's do one more example like that. Let's say we have y cubed minus y squared over y squared. You might be tempted to cross off the y squared over the y squared. You can't do that because you have a binomial in the numerator. But instead, what you would have to do is you'd have to rewrite it. Y cubed over y squared minus y squared over y squared. Now what you could do is, the y squared over the y squared, this becomes 1. So you can rewrite the whole problem, and you could write y cubed over y squared minus 1. But what else could you do over here? You still have a monomial over a monomial. The first part of this binomial is a monomial over a monomial. This can be reduced by doing division of a monomial divided by a monomial. You can totally cross down and make it 1, but y cubed over y squared becomes y. Because if you're dividing a monomial by a monomial, if they have the same base, you subtract their exponents and you keep it in the place of the higher exponent. So the higher exponent over here is in the numerator, so it would really become y over 1 minus 1, because we still have the minus 1 from over here. But you don't have to write y over 1, just like you don't have to write, just like 4 is the same thing as 4 over 1, and you don't need to write 4 over 1. So this, we could just rewrite this as y minus 1. Occasionally you might see a question where there's a monomial in the numerator and a binomial in the denominator. Let's say x over x squared plus y. You don't want to be playing around with this. You can't cancel anything out. You can't separate it into multiple terms. You're going to discuss this in Algebra 2. It's not really applicable for Algebra 1, so we're not going to discuss that now.